Hello. Very good evening, dear participants. The resource person for the program, Dr. D. Kumaresan sir, is with us. Very good evening,
Good
sir.
evening, ma'am. Very good evening, ma'am.
Yes, sir. Very good evening. So we shall start the session now.
Yes, ma'am.
Yes. Warm welcome and very good evening to one and all present for the fifth day of the one-week faculty development program on research methodology and statistical tools used in research, organized by PG Department of Commerce in association with IQAC and Research Cell of St. Teresa's Degree College for Women. I, Navyashri, PG Coordinator of the college, take the opportunity of hosting today's session. At the outset, I would like to welcome our eminent speaker, Dr. D. Kumaresan sir, for the fifth day of the faculty development program. We wholeheartedly welcome you, sir.
Thank you, madam.
Also, I welcome all the participants for the fifth day of the faculty development program. And today, sir will be emphasizing on the statistical tools used in the data analysis, which is one of the advanced version of a research methodology. So, hoping to listen from you a lot, sir. Without wasting much time, I will hand over the session to you, sir.
Thank you, madam. Thank you.
So please take over the session, sir. Thank you so much.
Yes, thank you. Very good evening to all of you. It's my immense pleasure to be the resource person on the day 5 of 1 week FDP, organized by St. Teresa's Degree College for Women. It's really a great endeavor of the St. Teresa's College for Women, Degree College for Women, because the efforts of the Department of Commerce and IQAC to organize such a program for the welfare of the faculty members, research scholars, and PG students to diffuse the knowledge about the research methodology and statistical tools used in research. So far, we have discussed various aspects about the research. Today and tomorrow will be the crucial day, and I think it is the climax. So here we have to learn the statistical tools. There are a number of tools. What is important about the statistical tools? The appropriateness. Appropriateness is the significant aspect about the statistical tool, because we have several tools, but which one is most appropriate for the particular analysis, for the particular data? So that is important. So selection of tools is dependent on the data variable and the data type. What we are going to analyze, what is the objective, what are the hypotheses, that and all we have discussed in the previous sessions. So here, based on the objectives, based on the hypothesis, based on the data type and variables, we are going to select the appropriate statistical tools. See, you know pretty well, a water tank at the top of the house is used to store the water. We know pretty well. It is constructed at the top of the house. In that water tank, huge volume of water is stored. So what is the purpose of constructing that water tank? To store the water in a huge volume and for several purposes, several uses. Okay. Inside the house, we have certain pots or vessels to store the water. The purpose of pot or vessel is also to store the water. But here the volume of water to be stored is less when comparing with the water tank. Here the use is to keep the water at home, inside the home, for limited purposes, for drinking purposes, for cooking purposes, even sometimes for sanitary purposes. So for different purposes, we store the water in different vessels. Then, while coming to the college, we are carrying a water can or water bottle. The purpose of water bottle is also to store the water. But we can carry the water can or water bottle wherever we go. Whereas in the case of pot or vessel, we cannot carry it. Suppose while coming to the college, can you carry that vessel? No. So only the water can or water bottle is carried with you. Okay. Then a tumbler or a glass or a cup. It is also to store the water, but the volume of water stored in the glass or tumbler is less. It is used to drink. It is used to drink water. So the purpose of all the vessels, all the containers is one and same. But for different uses, we use different containers. Likewise, statistical tools are also there. The purpose is to analyze, but the use is different. So based on that, we have to select the appropriate statistical tool. That's all. So basically, in statistics, we would have studied measures of central tendency and measures of dispersion. Measures of central tendency, measures of dispersion. Measures of central tendency are called averages, arithmetic mean, then median, mode, harmonic mean, and geometric mean. But of all these measures, the most widely used measure is mean, that is average mean or arithmetic mean. Average mean or arithmetic mean. That is the most commonly used measure of central tendency. Median is somehow different, mode is somehow different. Okay. Then in the case of measures of dispersion, we have range, interquartile range or quartile deviation, then mean deviation, then standard deviation. Apart from this, kurtosis, moments, and skewness are also there. Among these measures of dispersion, again, the most commonly used tool is standard deviation. So these measures are called parameters. These measures are called parameters. So mainly mean and standard deviation are called parameters. One more parameter is there, that is variance. Variance is the square of standard deviation. Variance is the square of standard deviation. Okay. Now, come to the mean. There are several numbers, several quantities. So, for example, marks obtained by the students in your class. there are 25 students. You have conducted a test, evaluated the papers, and awarded the marks. Now you prepare a mark list. Student number 1, 57 marks. Student number 2, 82 marks. Student number 3, 44 marks. Like that, you are preparing a list of marks. Okay. There are 25 students. See, each student has got different scores. Obviously, you cannot expect that all the 25 students have got the same marks. You cannot say, you can never say. If there are only 4 or 5 students, there may be a chance. But if there are 25 students, even 10 students are there, you cannot be sure, you cannot be certain that all the students have got the same marks. So there may be differences in the marks scored by each student. There are 25 students. Your principal is asking what is the average score obtained by your students in your subject. Or your management, correspondent or secretary or chairman is asking you to submit the mark list along with average. Because as a subject in charge, you can check the marks of each individual student. That is possible for you. As far as the head of the department is concerned, each class in charge, each subject in charge submits the report of each subject. Suppose there are 300 or 400 students in your department, the head of the department may feel difficult to check the marks of all the students. In spite of that, they are doing. That is different. But when we go to the principal or head of the institution, there are 3,000 students in your college. So it will be more difficult for principal or the correspondent to check the individual students' individual subject mark of all the 3,000 students. Suppose each student has 5 subjects, means 3,000 into 5, 15,000 marks are there. So can it be possible for a single person to check all the 15,000 marks individually? So we concise, we suppress in the form of mean, So in your class, in your subject, there are 25 students. Each student has got some marks, some different marks. So you are submitting the report to the head of the department. At that time, you are preparing mark list. At the end of the last student's mark, you are calculating the average. You are computing the mean. So what is the formula for mean? Sum of x divided by n. Sum of x means the total of all the marks divided by n. That is number of students. In our case, 25 students. So we get average marks. Likewise, you are submitting the report to the head of the department or class in charge. In your class, there are 5 subjects. 5 teachers are taking the classes. You are submitting the report to the head of the class in charge. He is consolidating. Then finally, all the class in charges are submitting the report to the head of the department. Then finally, all the heads of the departments are submitting the consolidated report to the principal. So in the final stage, only the average marks will be shown, because that only will be possible for the head of the institution to look at a glance of all the marks easily. Right. So mean is the single numeric representative of all the marks. So it is the average. Okay. Then what about the standard deviation? See, we have calculated average. Okay. It doesn't mean that all the marks scored by the students are equal to the average. No, it is a representative. That's all. All the marks may not be or need not be equal to the average. So there may be some difference for each individual mark to the average. See, for example, average is 65. First student has got 71. Second student has got 59. Third student has got 61. Like that, there may be some differences. That difference is known as deviation. So how far it is deviated. The deviation has different measures. Mean deviation. From the mean, we are calculating the mean deviation. From the quartiles, we are calculating the quartile deviation. But what about the standard deviation? That standard deviation is known as the standard limit within which the individual scores of each student will be there when compared with the average mark. Suppose 65 is the average. Standard deviation is 10, for example. So mean plus or minus standard deviation. Mean is 65. Standard deviation is 10. What is plus or minus 10? So the marks range will be 55 to 75. Because 65 minus 10, 55. 65 plus 10, 75. So the range of marks will be maximum, not all the marks. So maximum, it will be 55 to 75. 55 to 75. So for that purpose, standard deviation is calculated. Then as I told you, madam, I have not displayed the PPT. I will display. Archana madam. So here, variance is the square of standard deviation. Variance is the square of standard deviation. See here, when we come to the tools, now only we start. Tools can be basically divided into two types. Number one, parametric tests, and number two, non-parametric tests. Parametric tests and non-parametric tests. So far, you would have learned different meaning or definitions for parametric and non-parametric tests. For the sake of easy understanding, let me give you a simple definition. That is, a test is said to be a parametric test when any parameter is used. A test is said to be a parametric test when any parameter is used. What is a parameter? I told you, no, mean, standard deviation, or variance. If any of these three, like mean, standard deviation, or variance is used, or maybe sometimes combination of these, it is said to be parametric test. If no parameter is used, it is said to be non-parametric test. That's all. Very simple definition. So you can never forget this. It is easy to remember. It is easy to recall even. What is parametric test? When a parameter is used, it is parametric test. What is non-parametric test? When no parameter is used, it is said to be non-parametric test. That's all. Now, what are the parametric tests? What are the parametric tests? And when can we use the parametric test? Next question. When can we use parametric tests? And what are the tests classified as non-parametric tests, and when can we use the non-parametric tests? Is there any similarity between any of these parametric and non-parametric tests? Yes. Let us discuss one by one. In the case of parametric tests, we have one sample. Before that, let me tell you one more thing. It is easy to understand. Don't bother about the parametric tests. Oh, sir, I don't know, sir. How many tests are there? How can I understand, sir? It can again classified into two. Earlier, I told you tests are classified into parametric and non-parametric tests. If a parameter is used, it is said to be parametric test. If no parameter is used, it is said to be non-parametric test. Then again, parametric test is further classified into two. One is t-test and another is ANOVA. That's all. One is t-test and another is ANOVA. Very simple. Then come to t-test. T-test can be divided into three. One sample t-test, independent samples t-test, and paired samples t-test. One sample t-test, independent samples t-test, and paired samples t-test. That's all. So parametric t-test, one sample t-test, independent sample t-test, paired samples t-test. Parametric test, ANOVA. ANOVA can be divided into two. One-way ANOVA, two-way. That's all. So at any time, even while sleeping, you are asked, you can easily say what is parametric test, what is non-parametric test, what are the types of parametric tests, what are the types of t-test, what are the types of ANOVA. One sample t-test, independent sample t-test, and paired samples t-test. That is in the case of ANOVA, one-way, two-way. That's all. Then come to the non-parametric tests. Again, there are 5. Number one, chi-square test. Why I am emphasizing is, many of the scholars have a doubt, sir, whether chi-square test is a parametric test or non-parametric test. I've seen in some books that it is a parametric test. In some other books, it is given as a non-parametric test, sir. What is it, sir, in fact? Please, never bother about the previous learning. I am telling you surely that chi-square test is a non-parametric test, because as the basic definition I told you, no parameter is used here. So certainly it is a non-parametric test. Don't bother. So first one, chi-square test. Then come to next. Second test is Mann-Whitney U-test. Second one is Mann-Whitney U-test. It is in fact similar to the independent sample t-test. In the parametric test, I told you, one sample t-test, independent sample t-test, and a paired sample t-test. Here, Mann-Whitney U-test. It is similar to the independent sample t-test. So we call the Mann-Whitney U-test as a non-parametric equivalent to the independent sample t-test. Then, Kruskal-Wallis test. The third one is Kruskal-Wallis test. Kruskal-Wallis test is similar to one-way ANOVA. It is similar to one-way ANOVA. So it is called as non-parametric equivalent to one-way ANOVA. Then the fourth one is Wilcoxon test. Fourth one is Wilcoxon test. It is similar to paired sample t-test. So we call it as non-parametric equivalent to paired samples t-test. Then the last one is fragment test. Last one is fragment test. That's all. Here, Wilcoxon test is known as two related samples. Wilcoxon test is known as two related samples. And fragment test is known as k related samples. K means n number. Similarly, Man-Whitney test is two independent samples. Man-Whitney test is two independent samples. And Kruskal-Wallis test is k independent samples. That's all. Here in parametric test, in the case of independent sample t-test, it is two independent samples. One-way ANOVA, k independent samples. Paired samples t-test, two related samples. That's all. So with this introduction, let us go to the PPT. Yes. See, this is how we have to apply the test. That applications will be discussed tomorrow, because tomorrow is the hands-on. So one sample t-test. See, analyze, compare means, then we go to one sample t-test. Okay. Sir, where can I apply one sample t-test? It is very simple. You have taken certain samples, some 200 samples, 300 samples, or 500 samples, anything. In case you don't divide the samples, you divide all the samples as a single group. What is group? See, gender is a variable. If we divide the gender into two groups, male and female, age, we classify up to 20, 20 to 40, 40 to 60, above 60, like that. So there are four groups. Marital status, married, single, two groups. Education, up to school, up to UG, up to PG. So there are three groups. Occupational status, student, housewife, farmer, employee, businessman, professional. So there are 6 groups. Okay. So this is grouping of samples. Gender wise, we are dividing the samples into 2 groups. Age wise, 4 groups. Education wise, 3 groups. Occupational wise, 6 groups. Marital status wise, 2 groups. Like that we have divided. But instead of dividing the samples into groups, if you want to conduct a test on the whole samples without dividing them into subgroups, in that case, you have to apply one sample t-test. In this case, what we are doing, here it is, that is mean is compared. See, this is the gateway. Analyze, compare means. In all these tests, we are comparing the means. So compare means. So in one sample t-test also, the mean is compared. Sir, you told that the samples are not divided into groups. They are taken as a whole. So there can be only one group. That is why this test is called as one sample t-test. So there can be one sample means there can be one mean. But you are telling that it is coming under compare means. Sir, how can I compare? Here, the sample mean is compared with the population mean. So when you want to compare the sample mean with the population mean, in that case, you have to apply one sample t-test. For example, there is a company. There are different departments. And the employees are allowed to take 2 cups of tea every day. 2 cups of tea every day. It is normal. But even if you are taking 3 cups of tea, 4 cups of tea, no question will be there. But you have to enter. I belong to this department. So whenever you go to the canteen, you have to enter your attendance or something like that. Biometric attendance is there. You can have any number of cups of tea. That is, there is no restriction. The question is, the standard number of cups of tea allowed is 2 per day. Okay. Now, the company finds that a particular department employees take more cups of tea. A particular department employees or staff are taking more cups of tea. This is the question. Now we have to test with the statistical evidence. We have to prove it with statistical evidence. That is called scientific report. So before alleging that you are consuming more cups of tea, we should never allegate without any documentary evidence. So just we are testing. How to test? What is the average number of cups of tea taken by all the employees of the company? That is called population mean. Understand? Okay. Then, what is the average number of cups of tea taken by this particular department staff? We are comparing. So population mean is compared with one sample mean. In that case, we have to apply one sample t-test. That's all. Very simple. So what is the comparison here? Comparison of population mean and standard mean. I mean sample mean. That's all. There is no grouping of samples. Only one group is taken. Maybe you may be asking, sir, there are several departments. How can you say that they are not divided into groups? We are taking only one department. That department employees are not divided further. Okay. So one sample t-test can be applied to compare the means of population and one sample. Understand? Then the next one is, look at this, independent sample t-test. So obviously next one, the independent sample t-test. I told you, independent sample test is a 2 independent samples is concerned with 2 independent samples. So what is 2 independent samples? In the previous one sample t-test, I told you the samples are not divided into groups. Suppose if samples are divided into 2 groups, in that case, we have to apply independent sample test. So gender is divided into 2. Gender is divided into 2. Age is divided into 4. If there are 4 groups, we should not apply independent sample test. If there are only 2 groups, like gender, marital status, nature of family, nuclear family and joint family, single and married. In that case, we can apply independent sample street test. If there are more than two groups, like age is divided into 4, area of residence is divided into 3, education is divided into 3, occupational status is divided into 6, like that. If there are more than two groups, then we have to apply one-way ANOVA. If there is only one group, entire sample is taken as one sample, you have to apply one sample t-test. If it is divided into two groups only, in that case, we have to apply independent sample t-test. If there are more than two groups, we have to apply one-way ANOVA. Then what is paired sample t-test? When should I apply paired sample t-test? I told you, no, paired sample t-test is used for two related samples. Earlier, the previous one is independent sample t-test. There are two independent samples. Independent samples means mutually exclusive. The member of one group cannot be a member of another group. See, male cannot be categorized as female, is it not? So, a member in this category cannot be a member in another category. That is called independent. When we come to the paired samples, it is two related samples. It is two related samples. So in this case, there is only one sample. There is only one sample, like one sample t-test. We are not dividing them into groups. But what is compared here? The same group is compared with the same group. Sir, we are not clear, sir. Yes, sir. Let me tell you, sir. Paired sample. So the group figures before certain event and group figures after a certain event. Same members, same class. See, in your class, you have prepared a mark list of first cycle test and second cycle test. You are comparing first cycle test and second cycle test. You are comparing. In that case, we are comparing only two related samples. It is said to be paired samples t-test. In that case, we have to apply paired samples t-test. If k related samples are there, more related samples, first cycle test, second cycle test, third cycle test, then pre-semester test, then semester test. You are comparing the same group of students. Marks in different subjects. I mean, marks in different examinations. Marks of the same subjects, understand? Marks of the same subjects. You are comparing. Or sometimes we are comparing marks obtained by the same students in different subjects. Unlike I told you, no, first cycle, second cycle, third cycle, pre-semester and semester examinations. Or otherwise, marks in income tax, marks in investment management, marks in supply chain management, marks in HRM, marks in marketing management. Same students. In that case also, it is called k-related samples. In that case, we have to apply correlation. Carl Pearson's correlation, we have to apply. So these are the parametric tests. Is there any condition for applying parametric tests. Yes. You know, I told you yesterday, variables are divided into two: dependent variable and independent variable. What is dependent variable? That variable is dependent on any other variable. It is said to be dependent variable. Then independent variable is not dependent on any other variable. In the inferential statistics, we are comparing two variables, variable 1 and variable 2. In that case, one variable may be independent and another variable may be dependent. Now, so far we discussed about the groups. No, this grouping is about the independent variables only, like gender, age, education, occupational status, income, nature of family, marital status. These are all what? Independent samples. What about the dependent variable? I told you, no, marks, weight, height. These are all measurements. These are all measured. These measured data are called dependent variable. We say that these variables may dependent on the independent variables. According to the age, the score may differ. The height may differ. The weight may differ. The IQ may differ. Is it not? So the weight, height, marks, or IQ, EQ, emotional quotient could be, understand, could be dependent on age, gender, educational level, occupational status, marital status, like that. So we are comparing. So age is not dependent on anything. Gender is not dependent on anything. Education is not dependent on anything. Occupation is not dependent on anything. Income is not dependent on anything. If it is so, they are called independent variables. This grouping is all about the independent variables. What about the dependent variable? In the case of dependent variable, the data must be a measured data. That measured data is called scale data. Measured data is called scale data. Measurable in quantities. Measurable in numbers. See, for gender, male and female, we are assigning 1 and 2. That is not measurement. That 1 and 2 has no values. It is just assigned to identify or to differentiate the samples. So 1 means male, 2 means female, like that only. Whereas weight is measured, height measured, marks measured. Okay, it is called scale data. So for applying parametric tests, the main criteria is the dependent variable must be a scale data. This would be the result of the independent sample t-test. Then this is about the paired sample t-test. That is all we are going to discuss tomorrow. So this is the way how to apply one way. So as I told you, very simple. There are two variables. One is dependent and another is independent. Dependent variable is a scale data. Okay. That is measurable. Independent variables are not dependent on any other variable. They are not, they may or may not be measurable. They may or may not be measurable. They are classified into different groups. Okay. If there are two groups, we have to apply independent sample t-test. There is only one group, we are applying one sample t-test. We are comparing the same group at two different situations, before and after, first test and the second test, pre-final and final. In that case, we have to apply paired samples t-test. If there are more than two groups, we have to apply one-way ANOVA. We have to apply one-way ANOVA. What about two-way ANOVA? In the case of two-way ANOVA also, there are more than two groups. But in the test so far, we have discussed one sample t-test, independent samples t-test. I leave the one sample t-test because we compared the sample mean with the population mean. In the case of independent sample t-test, there is only one independent variable and one dependent variable compared. Okay. In the case of paired sample t-test, only one sample, no group. But a pair of data are compared. That is pre-final and final, or pre-test and post-test, like that. See your IQ about research methodology, pre-FDP and post-FDP. Suppose if you that score is calculated, we can apply paired samples t-test. One-way ANOVA, there is also only one independent variable. See, age is compared with the score. Age is compared with the weight. That's all. Sometimes, if you want to compare two independent samples with a single two independent variables with one dependent variable. Understand? Earlier, in the case of one-way ANOVA, only one independent variable and only one dependent variable. In the case of two-way ANOVA, two independent variables and one dependent variable. That's all. So that is the difference between one-way ANOVA and two-way ANOVA. So for two-way ANOVA, we have to go to this gateway. Again, analyze general linear model. Then you go to univariate. Then this is the way how to get the tool. So this is all about the parametric test. Basically 5. I have added one more, that is correlation. One sample t-test, independent sample t-test, paired sample t-test, one-way ANOVA, two-way ANOVA, and correlation. That's all. Now come to the non-parametric tests. First one I told you, chi-square test. In the case of chi-square test, see the major difference between parametric and non-parametric test. I told you, when a parameter is used, it is parametric test. When no parameter is used, it is non-parametric test. Yet another important distinction between parametric and non-parametric test is there. In the case of parametric test, I told you the dependent variable must be a scale data. Must be a scale data. Whereas independent variables may be nominal data or ordinal data. Now, in the case of non-parametric tests, the dependent variable is not a scale data, it is an ordinal data. See the difference. In the case of parametric tests, dependent variable is scale data. In the case of non-parametric test, dependent variable is an ordinal data. Okay. Then another important distinction is that the parametric test can be applied only when the data are normally distributed. Only when the data are normally distributed. Whereas in the case of non-parametric tests, that normalcy is not required. Whether it is a normally distributed data or not normally distributed data, in both of the cases, we can apply non-parametric test, but the condition is dependent variable must be an ordinal data. If it is a scale data, go to parametric. If it is ordinal data, go to non-parametric. That's all. See, this is the way how to apply the non-parametric test. First one, chi-square. Second one, 2 independent samples. Third one, k independent samples. Fourth one, 2 related samples. Fifth one, k related samples. But even though, say I told you, no, chi-square is a non-parametric test, it is shown here, no? Yes. So definitely, don't forget, chi-square test is a non-parametric test. Okay. But there is yet another gateway to apply chi-square test. That is, go to analyze, then go to this one, second one, descriptive statistics. Then you can get a submenu. In that case, you will be getting, the crosstabs. You have to select crosstabs. So what is row item? What is column item? Then you have to select the statistics. In that case, you will select the chi-square test that we will discuss tomorrow. So next one is 2 independent samples t-test. It is almost similar to independent samples t-test. Here, again, as I told you, independent variable is divided into 2 groups only. Understand? Like male and female. In the case of independent sample t-test also, in the case of independent sample t-test also, there were only 2 groups of independent variable, male and female. But what was the dependent variable? We compared marks or weight or height. Is it not? It is measurable. So it is a scale data. It is a scale data. What is the difference between independent sample t-test and Mann-Whitney U-test? In this case, irrespective of the independent variable, here also independent variable is divided into 2 groups, no doubt at all. What about the dependent variable? That dependent variable is not a scale data. It is an ordinal data. Sir, can you give any example? Yes. If you are given marks obtained by the students, it is a scale data. In that case, you have to apply independent sample street test. Sir, I am given ranks. I am given ranks, not marks. If ranks are given, it is ordinal data. It is not scale data. If ranks are given, you have to apply non-parametric tests. Or sometimes grades are given. Sometimes grades are given. Outstanding, excellent, very good, good, fair, poor. Or sometimes we are using Likert scale, no. Highly satisfied, satisfied, neutral, dissatisfied, highly dissatisfied, strongly agree, agree, neutral, disagree, strongly disagree. Frequency of usage, always, often, sometimes, rarely, never. It is also ordinal. High, moderate, or medium, low. It is also ordinal. First rank, second rank, third rank, fourth rank, fifth rank, sixth rank. It is also ordinal. When the dependent variable is collected as an ordinal data, or it is given as ordinal data, you have to apply non-parametric tests. And if the independent variable is divided into two independent groups, like male and female, married, unmarried, or married, single, nuclear family, joint family, UG, PG, student, staff. If the division is made like this, we have to apply two independent samples, non-parametric test, that is called Mann-Whitney U-test. Mann-Whitney U-test. Look at this. Mann-Whitney U-test is selected. Two independent samples t-test. Then the next one is K independent samples t-test. In the case of K independent samples t-test, there will be more number of groups, more than two groups. That is next one. Kruskal-Wallis test. Okay. Kruskal-Wallis test. That is K independent samples. Like one-way ANOVA. Independent variable is divided into more than two groups. Suppose if gender is divided into three, male, female, and transgender, there are three groups. Then you should not apply Mann-Whitney U-test. You have to apply K independent samples. That is Kruskal-Wallis test. That's all. Okay. Then we'll move on to the next one. Two related samples. It's like a paired sample t-test. I told you, no, paired sample t-test, before and after, pre and post, pre-final and final, like that. Similarly here also. But instead of giving the marks or weight, suppose weight is given, we have divided the weights into three: high weight, normal weight, low weight. High weight, normal weight, low weight. So high, normal, low, that's all. Not the weight, kilograms are not given. Understand? It is ordinal data. See, suppose they are going for a course. weight reduction course or weight increasing course, like that. In that case, they want to test whether the weight is increased or decreased, like that. If a single person is concerned, you can just compare the weights. You are running a center, health center you are running. You want to test whether the customers' weights have increased or decreased. In that case, instead of taking the actual measures of weights, you are classifying them into three. Obesity, that is overweight, normal weight, low weight. Overweight, normal weight, and low weight. Okay. Now the customers are divided into age groups. Customers are divided into age groups. There are 4 age groups. If male and female are compared, you can apply man weight NEU test. If age group is compared, then weights are compared. In that case, only one dependent variable. Understand? Only one dependent variable. Just weight measurements are compared. That is the overweight or normal weight or low weight is checked. Then K independent sample test. That is Kruskal-Wallis test. Now, what about two related samples? Again, the weight measurements, that is obesity, normal, and low weight. But before the course, after the course. Before the course and after the course. So it is said to be two related samples. In that case, we have to apply Wilcoxon test. Wilcoxon test is similar to paired samples t-test. Then the last one is K-related samples. There may be more than 2 related samples. Again, the same health course is conducted for 4 months. For 4 months, you are dividing that you are comparing weight after first month, after second month, after third month, after fourth month. Before and after the course means there are only 2 related samples. First month, second month, third month, fourth month means there are more than 2 related samples. In that case, we have to apply the last one, that is called Fragment's rank test. Fragment's rank test. That's all. So that's all about the non-parametric test. I told you no, 2 related samples, then K related samples. Like that, you have to go to analyze non-parametric tests, legacy dialogues, 2 independent samples, K independent samples, 2 related samples, and K related samples. So that's all about the tools. These are the basic tools we are applying. Advanced tools are there, more tools are there, advanced tools. But 1 hour is not sufficient to discuss all the tools. So we have discussed so far about the basic tools, parametric and non-parametric tests. Generally, I told you no, parametric test is applied when there is a parameter used. If no parameter is used, it is said to be non-parametric test. And the condition is, in the case of parametric test, the dependent variable must be a scale data. In the case of non-parametric test, it should be an ordinal data. That's parametric test is subdivided into 2 groups, t-test and ANOVA. T-test is further divided into 1 sample t-test, independent sample t-test, and paired sample t-test. ANOVA is divided into 1-way ANOVA, 2-way ANOVA. In the case of non-parametric test, chi-square test, 2 independent man weight NEU test, Kruskal-Wallis test, Wilcoxon Test and Fragment Test. That's all. So it's a time for you to ask questions. With this, I would like to thank the organizers and all the participants for the patient listening and the wonderful opportunity. Thank you, one and all, once again. Now the forum is left open for questions. Thank you very much.
Thank you, sir. Thank you for explaining the advanced concepts of research, that is measures of central tendency, measures of dispersion, and the various statistical tests in a simplest way. And I must tell this, you have captured us for the one last hour so that we could lose the track of the time. So thank you so much for your wonderful explanation, sir.
Thank you very much.
So now I request the participants to put your queries in the chat box, if you have any. I don't find any questions in the chat box so far. Participants, please feel free to
You can unmute and ask the question.
Yes, you can even unmute yourself and ask the question if you have any.
Angel, Puspalada, Pooja, thank you very much. I'm sorry, whether my voice was not audible?
It was clear, sir.
Okay. Anand Kumar has given a comment in
Yes.
the chat box. Yogita, thank you.
So,
Is
dear
there any
participants,
or even you can give a feedback.
yes, we have 1 day left. So the participants can give a feedback by unmuting yourself. It's almost 5 days up and you have learned a lot of concepts in research, right from the basic level till the advanced version. Sir has been teaching us, and it was a wonderful session for these past 5 days, and hoping for the best for the upcoming day, that is for tomorrow. As sir told, tomorrow will be the climax of the particular FDP, and also we'll be learning advanced level of statistical tool, especially the software package of the social sciences, that is SPSS.
Madam, excuse me, do they have the SPSS installed in their laptops or computers?
I don't think most of them will be having it, but hopefully few of them will be having it, sir.
Better. Dear participants, please install the SPSS, at least the student version, in your laptop or computer, so that you can have hands-on experience tomorrow. Okay.
Yes.
Yes.
Thank you for your suggestion, sir.
Yes.
So dear participants, kindly install the SPSS software in your system so that you can learn about the concept practically and you can get a practical exposure towards the SPSS application. So with this, I think there are no questions from the participants.
Okay, ma'am. Thank you.
So we shall wind up the session for the day. So thank you so much, sir.
Sure,
Thank you so much for your wonderful presentation, and we will all join back tomorrow at 5:30.
Yes, ma'am.
Once again, thank you.
Today
Yes.
I have another session now. It is going to be started very soon. So I'll send you the PPT later. Huh?
Sure, sir.
Okay. Thank you very much, ma'am.
Thank you, sir. Thank you all, dear
Have a good day,
participants.
all of you. Good night.
Thank you, sir. Bye-bye, everyone.